we are ready to take a look at just one more hypothesis test here regarding proportions. So it says that a decade-old study found that the proportion of high school seniors who believed that getting rich was an important personal goal was 70%. A researcher decides to test whether or not that percentage still stands. He finds that among 240 high school seniors in his random sample, that 184 believe that getting rich is an important goal. At a 0.05 level of significance, test the claim that the proportion has indeed changed. Okay, so let's focus on our hypotheses and the claim being tested. So the researcher is claiming that the proportion has changed from what it was in this decade-old study. So back then, they said that 70% of seniors felt that getting rich was an important personal goal. So the researcher wishes to test the claim that this has changed. So not claiming it's higher or lower, just not that it's 70% anymore. So this is our two-tail test. The researcher just thinks that it's no longer 70%. So has changed. All right, not equal to. So this is our two-tail test. So our null hypothesis with equality. So we've got our p0 of 0.70, center of our picture there. So there's the graph of our null hypothesis. And then the researcher goes out and gets some data to see if we have evidence against this proportion. So he samples 240 and 240 high school seniors, and X, the number of successes, 184, believe that getting rich is an important goal. Alpha 0.05 or 5%. All right, so before I do the sample proportion and test value, let's go through traditional method just to make sure we're good here with a two-tail test. All right, so for a two-tail test, we have our alpha of 0.05, but for a two-tail test, half of alpha will be on each side, so in each tail of our distribution. So for two-tail tests, we need to remember to divide our alpha by 2. So for the critical value z, and I'm sorry, it's plural, critical values z, there'll be 2 of them, plus or minus. So we'll have one on left and one on right. So you're going to inverse norm your alpha over 2 value. And that will give you one of those z-scores, and then we just remember the plus minus part. So that one is going to give you the negative z-score, 1.96. But we know we've got 2 z-scores for a two-tail test, so plus or minus 1.96. All right, so let's put those in. Critical value, negative 1.96. Critical value, 1.96. So that area on the right tail, alpha over 2. The area in the left tail, alpha over 2. And therefore, we've got 2 critical regions, one to the far right, one to the far left. And our unshaded region there will be our non-critical region. All right, so again, setup is always the same, right tail, left tail, two tail. But the change here is we're looking at proportions. So we're going to run our one proportion z-test. And our p0 is 0.70, x is 184, n is 240. we're doing a two-tailed test, so not equal to. I'll go calculate. And now I'm seeing my p hat. I just want to write that down. So I'll round it to 2 places just to make it easy to discuss here. So that p hat 0.77, so 77%. So the null hypothesis is that the proportion is 70%. Our sample proportion is different. The question is just how different is it? And is it far enough from 70 to convince us 70 is incorrect? And the way we determine that is to look at its test value, and that is 2.25. So we'll graph our test value. The 2.25 is going to be out here, which means that that p hat, that 77%, that 0.77, does make it into the shaded critical region. So it is far enough away from 70% to convince us that 70% is likely not the proportion any longer. So it does appear that it's different, but we got something so far. In this case, the test value location into that right tail critical region. So the test value falls in the critical region, which means we do have enough evidence to reject H. And then we'll do our p-value method, making sure then that we reach that same conclusion, just in a different way. So for the p-value method, we graph, there's no critical region, we just graph our test value. So test value 2.25. That tells us where our p hat is. And that area beyond the test value for a two-tailed test, this is just half of the p-value area. So again, just like alpha had been split in half, the total p-value, half of it will be on one side, half on the other. So to just draw the picture on the other side, we'll take that test value and look at its partner on the other side. So this isn't a new test value. It's just the opposite sign of the test value that allows us to shade in the other half of the p-value. So we don't need to find that actual numerical value, p-value over 2, p-value over 2. The calculator will give us the total area together, and that's what we'll compare to the total area of alpha. All right, I can see visually though on my picture that my p-value is going to be smaller than my alpha. You can see it up here, this 0.77 is there. So beyond the 0.77 is the p-value over 2 area. So I can see that my p-value is going to be smaller than my alpha. Technically, we say less than or equal to. And I also knew that because we rejected H naught when we did our traditional method. And when your p-value is low, that's when you let the null go. So it's like a big puzzle that should all fit together. And we'll confirm our p-value is smaller than our alpha numerically by checking out the calculator. So the p-value is 0.0242 or 2.42%. So those two areas together are 2.42%. Our alpha was 5%. So indeed, our p-value is smaller than our alpha. And we just say less than or equal to, again, technicality here. All right, and when our p-value is low, we let the null go. So it's all coming together. And when we reject our null hypothesis, we are supporting our claim. So at a 5% significance level, and based on a sample of 240 seniors, reject the null, there is evidence, enough evidence to support the claim that the proportion, we could say percentage as well. I was just going up and seeing the wording. They said proportion. So that the proportion has changed from what it was a decade ago, or has changed from 70%. So that the proportion of high school seniors who believe getting rich is an important personal goal has changed since a decade ago. All right, and there you go. There is an example of a two-tailed test of a population proportion.